In this particular problem from my math lab, we're asked to use the formula for computing continuously compounded interest. Okay, so for continuous compounding, we need to know what the formula is. And the formula is A, the amount in the account, equals the amount deposited, that's the principal, times E, and E is just an irrational number, and we'll look at that on the calculator, and that's raised to the rate of interest, the annual percentage rate. Let's see, that's the APR. And we're going to multiply that times the number of years. And all that's in the exponent. Okay. Now, when we get ready to use this E here, over in the calculator, if you'll notice, it's located right here. Let me do it with something a little bit darker than that. Or brighter. Well, change this. Okay, this is where E is located. Notice that it's E to some power, and since that's in a blue function, we're going to have to use this second key to help us get to that. Okay, so if we're trying to calculate E to some power, we're going to do second and then the ln key, and that'll give us E to the x. Okay, so let's see if we can compute this balance in the account after 1, 5, and 20 years. Okay, so we start off with the amount's going to be $7,000 times E raised to, and writing the APR as a decimal is 0.032 times the number of years, which is 1. And then we're going to calculate that. I'm going to have to wait just a moment to do the calculation because I'll lose this writing. So you need to jot this down. To calculate the next one, we're going to have the amount equals 7,000 times E raised to the 0.032 times 5 for 5 years. And we'll calculate that. And then for the third one, we've got 7,000 times E raised to the 0.032. And this time it sits in the account for 20 years. And we're going to see how much is in the balance with that one. Okay. So to do these calculations, I'm going to need to exit the drawing and come over here to my calculator, and we're going to type this in. So the first one is 7,000 times E. So E is right here. We get to that by doing second ln. See, that gets us E, and our exponent's sitting there waiting for us. 0.032 times 1. And so our first answer is this, $7,227.62. We want to do the same thing for 5 years and 20 years. Now, we could type it all back in like this, 7,000 times E, second ln, 0.032 times 5. That's for 5 years. Or we could just say, re-enter the last thing that we just had. And to do that, notice that says entry up here in blue. So I'm going to do second enter. And I'm just going to back up to the number of years, and I'm going to change that to 20 years. And then I'm ready to calculate, enter. Okay, so these are our 3 answers for the problem. That's how much is in the account at the end of 1 year, 5 years, 20 years. Okay, so let me see if I can jot these answers down for us real quick. Okay, so in 1 year, it was 7,227, and it's asking us to round off to the nearest cent. So that's 62 cents. That's for 1 year. For 5 years is 8,214 and 58 cents. Notice that the way we're rounding this is we're looking at the third decimal place to round that up. And then for the 20 years is 13,275. And this would be 37 cents because we're looking at the 6 here to round that up. Now, you're also asked to find the APY. And APY we looked at earlier is the same thing as finding it's the same as finding the relative increase in 1 year. So the difference here from this 7,000, this was the 1 year, $227.62. Subtract 7,000. That's our difference. Whoa. And then we want to divide by the original, and the original was 7,000. So punching all that into our calculator, what it ends up producing here is 0.0325, and then the next digit is a 1. And when we did this earlier, we rounded it off to 2 decimal places as a percentage. I'm not sure if they're asking for 2 or 1 here. So writing this as a percent, if it's asking for 2 decimal places, it looks like this, 3.25%. And if they're asking for 1 decimal place, then it would be 3.3%. I hope this helps.